Out there in the profound and silent dark between the stars, giants are screaming. Not with sound which cannot travel through the vacuum of space, but with a form of light so alien to our biology that for all of human history we were utterly deaf and blind to the spectacle. It is a broadcast of pure power, a furious symphony of accelerated particles and twisted magnetic fields, a shout of energy so immense it echoes across billions of years. If you could somehow tune your senses to these frequencies filtering out the gentle hum of our own galaxy, the quiet night sky would erupt into a terrifying blazing panorama. You would witness an invisible war, a story of cosmic violence and creation written in static and light, a war waged by the loudest, most dominant objects in the entire universe. These are the radio galaxies, the universe's ultimate cosmic loudspeakers, and their roars of creation and destruction shape the very fabric of the cosmos we inhabit. To begin to understand their colossal nature, you must first forget what you think a galaxy looks like. Erase the image of the serene swirling spiral of the Andromeda Galaxy, or the soft hazy glow of a familiar elliptical. What we see with our eyes, that delicate tapestry of starlight, is merely the ghost in the machine. It is the quiet, unassuming facade for a monster of unimaginable scale and ferocity. Let us travel to a patch of sky that appears to even our most powerful optical telescopes as little more than an unremarkable smudge of light, a galaxy catalogued as Hercules A. It seems calm, a distant self-contained island of perhaps 1 trillion suns glowing with the ancient golden light of its aging stars. It sits there placidly in the constellation of its namesake, a portrait of cosmic tranquility. But this is a lie, a profound deception. Now we shift our perception. We dial down the familiar frequencies of visible light and tune our instruments to the invisible realm of the radio spectrum. As we do, the universe transforms. The quiet smudge of starlight, that gentle elliptical galaxy, remains as a tiny, insignificant anchor point at the center of the frame. From this tiny core, 2 colossal structures now erupt into view, ghost-like and terrifying. They are phantom arms, ethereal plumes of incandescent plasma, stretching out from the galaxy's heart, dwarfing their parent. These are the radio lobes, the visible manifestation of the galaxy's scream. They are not made of stars or dust or gas in any conventional sense. They are immense bubbles of plasma, electrons and protons accelerated to nearly the speed of light, held captive by magnetic fields of breathtaking complexity and strength. They are celestial blowtorches, twin jets of energy fired from a central engine, punching through the galaxy and inflating these colossal balloons in the near-perfect emptiness of intergalactic space. You're not looking at something inside the galaxy. You're looking at a structure that makes the galaxy itself seem like a mere speck of dust. From tip to tip, this ethereal phantom spans over 1.5 million light-years. To put that into perspective, our own Milky Way galaxy, a vast metropolis of 400 billion stars, is a mere 100,000 light-years across. You could fit 15 Milky Ways end to end inside this single invisible structure being broadcast by Hercules A. This is not a galactic event. It is a cosmological one. The galaxy we see with our eyes is just the cannon. These lobes are the cannonballs still glowing hot from the force of their ejection, travelling across distances that defy human comprehension. These are the universe's phantom limbs, the ghostly evidence of an energy release so catastrophic that its effects are felt on the scale of galaxy clusters. And Hercules A is not unique. It is merely one of a vast chorus of these cosmic broadcasters, their silent shouts filling the entire sky. Wherever we tune our radio telescopes, we find them. Cygnus A, one of the first to be discovered, a powerhouse so bright in radio waves, it was initially mistaken for a nearby object, its lobes ploughing through the intergalactic medium with visible shock waves like the bow wave of a battleship. Fornax A, a gentler giant, its lobes appearing like giant smoky rings, the ghostly remnants of past eruptions from its core. M87, a true monster in our own cosmic backyard, whose jet is so powerful we can see it in visible light, a brilliant blue needle of plasma, a stream of relativistic particles over 5,000 light-years long, being fired from a black hole of nightmarish proportions. Each one is a testament to a process that unleashes more energy in a single second than our Sun will produce in its entire 10 billion year lifetime. This brings us to the first great mystery of the radio galaxies, the sheer, unapologetic violence of their energy output. The light from the stars in the host galaxy is a whisper. The radio emission from the jets and lobes is a deafening roar. To create these structures to accelerate matter to these incredible speeds and inflate these magnetic bubbles to sizes that dwarf entire galaxies requires an engine of unparalleled efficiency and power. A single supernova, the catastrophic death of a massive star, is one of the most energetic events we know capable of briefly outshining its entire host galaxy. But you would need to detonate billions upon billions of supernovae all at once in the same tiny spot to even begin to approach the energy required to power a radio galaxy like Cygnus A. What kind of engine can do this? What sits at the heart of these seemingly ordinary galaxies hoarding and then unleashing such incomprehensible power? The answer lies at the nexus of creation and annihilation, a place where the laws of physics are stretched to their breaking point. The prime suspect, the only object we know of capable of orchestrating such cosmic mayhem, is a supermassive black hole. Not the stellar mass black holes left over from dying stars, but a different class of beast entirely. These are the gravitational hearts of their galaxies, behemoths, weighing millions or even billions of times the mass of our Sun condensed into a single point of infinite density. They are the cosmic anchors around which their galaxies spin, the quiet tyrants ruling from a throne of darkness. But a black hole on its own is passive. It only consumes. To create the magnificent, terrible structures of a radio galaxy, the beast must be fed. When gas dust and even entire stars from the host galaxy are drawn into the black hole's fatal embrace, they don't fall straight in. Instead, they form a swirling incandescent whirlpool of matter called an accretion disk. Here matter is heated to millions of degrees, crushed and torn apart by unimaginable tidal forces and friction. The disk becomes a celestial furnace blazing with a light so brilliant it can outshine all the stars of its galaxy combined. It is from this chaotic, hellish environment, this final cosmic traffic jam before the point of no return, that the jets are born. Twisted, powerful magnetic fields generated within the spinning disk and anchored to the rotating black hole itself act like a colossal cosmic particle accelerator. They ensnare a fraction of the infalling matter, a tiny percentage that escapes the black hole's clutches and funnels it outwards away from the event horizon. This material is then accelerated along these magnetic field lines focused into two tight coherent beams, and blasted out into intergalactic space at over 99% the speed of light. These are the jets. They are not simply fountains of hot gas. They are conduits of pure energy, gravitational potential energy converted into kinetic fury with terrifying efficiency. They are the exhaust ports of the universe's most powerful engines. For millions of years, sometimes tens of millions of years, these jets will fire relentlessly, drilling through the host galaxy's own interstellar medium and out into the vast empty void beyond. When this hyper-relativistic beam finally begins to slow down as it collides with the tenuous gas that exists between galaxies, it inflates, spreading out to form the giant luminous radio lobes. The lobes are the graveyards of the jet particles, the place where their kinetic energy is finally dissipated and converted into the radio waves our telescopes can detect. They are the glowing, expanding tombs of a cosmic sacrifice, a monument to the power of the central engine. To witness a radio galaxy, then, is to witness a conversation between the infinitesimally small and the incomprehensibly large. We are seeing a singularity, a point of zero volume and infinite density, projecting its influence across millions of light years. It is a single object, a gravitational anomaly smaller than our solar system, fundamentally reshaping the environment on a scale that contains thousands of galaxies like our own. This is the brute fact we are forced to confront. The universe is not governed solely by the gentle light of its stars. It is sculpted, bullied, and architected by these hidden monsters, these gravitational gyroscopes at the heart of galaxies whose periods of activity and dormancy dictate the fate of everything around them. This realization forces us to ask a more profound question. Why should we care? Why does understanding these cosmic behemoths, these loud but invisible phantoms, matter? Because they are not mere curiosities. They are fundamental actors in the grand drama of cosmic evolution. They are the key to understanding the very structure of the universe on its larger scales. The colossal jets and lobes do not expand into a true vacuum. They push against a faint, almost imperceptible web of gas that connects all galaxies, the so-called cosmic web. By blasting into this medium, they heat it, ionize it, and push it around, carving out vast cavities and creating shock waves that can trigger or quench the formation of new galaxies. The energy pumped out by a single radio galaxy over its lifetime is enough to fundamentally alter the evolution of its entire host galaxy cluster. The jets can blow out the cold gas needed for star formation, effectively sterilizing its parent galaxy and its neighbours for billions of years, turning them into the red and dead elliptical galaxies we see today. In this sense, radio galaxies are the universe's great regulators. They are a form of cosmic feedback, a self-regulating mechanism that prevents galaxies from growing too large too quickly. The very black hole that a galaxy feeds in turn can switch on and starve the galaxy that sustains it. It is a cycle of galactic life and death, of feast and famine playing out over cosmological timescales. Furthermore, they are cosmic miners and smelters dredging up heavy elements forged in the heart of the galaxy and distributing them far out into the intergalactic medium. These elements, the carbon, the oxygen, the iron, are the building blocks of future stars, future planets, and perhaps future life. The jets are a galactic distribution system enriching the pristine hydrogen and helium of the cosmic web with the materials necessary for cosmic complexity. Without these loud, violent outbursts, the universe might be a far more sterile and simple place. They are not just agents of destruction, they are agents of creation, enriching the cosmos and seeding the future. This is our thesis, the core of our journey together. To comprehend the universe as it truly is, its grand architecture, its intricate web of connections, its cycles of birth and death, we must learn to listen to its loudest inhabitants. We must decode their radio screams, for these are not random bursts of static. They are history, they are physics, they are the story of how the universe became the place we know. They tell us about the behaviour of matter in the most extreme environments imaginable. They are probes of the vast empty spaces between galaxies, revealing the faint ghostly tendrils of the cosmic web. They are the fingerprints of the invisible giants, the supermassive black holes that lurk in the centre of nearly every galaxy, including our own. For billions of years, this cosmic broadcast went unheard, the evidence of this incredible power washing over our planet completely undetected. The sky we saw was a serene and peaceful place, but we were only seeing a fraction of the truth, listening to only one instrument in a vast cosmic orchestra. Now our technological senses have been opened. We have built the tools to see the invisible and hear the silent screams that fill the void. The story of how we stumbled upon these cosmic phantoms, how we slowly, painstakingly pieced together the puzzle of their existence, is a testament to human curiosity and ingenuity. It is a journey that began not in a gleaming observatory, but with a strange, persistent hiss in a transatlantic radio receiver, a ghost in the machine that would ultimately change our view of the universe forever. What is the loudest sound you have never heard? It's not the whisper of a secret or the footfalls of a predator. It is a roar of such titanic proportions that it dwarfs the energy output of entire galaxies, a relentless scream of particles accelerated to nearly the speed of light. This is the sound of the radio universe, and for almost all of human history we were utterly deaf to it. We lived our lives wrapped in a profound cosmic silence, staring into a sky we thought we knew, charting the placid, predictable waltz of stars and planets. We saw a universe of elegant light, of incandescent spheres hanging in a velvet void, but we were seeing only a sliver of the truth, perceiving only one note in a symphony of unimaginable violence and power. The cosmos was shouting, and we had not yet evolved the ears to listen. That evolution began not in a grand observatory atop a remote mountain, but in a muddy field in Holmdel, New Jersey. The year was 1931. The world was grappling with the Great Depression, its gaze turned inward to troubles on a painfully human scale. Yet at Bell Telephone Laboratories, a young unassuming physicist named Carl Jansky was tasked with a problem that seemed at first entirely terrestrial. Bell Labs wanted to build a transatlantic radiotelephone service, a marvel of modern communication. But the ambitious project was plagued by a persistent and frustrating problem, a steady faint hiss of static that threatened to drown out any conversation. Jansky's assignment was simple, if not easy: find the source of this noise and eliminate it. He was in essence the universe's first pest exterminator. To hunt his quarry, he constructed a bizarre antenna, a contraption that would have looked more at home in a science fiction story than a New Jersey field. It was 100 feet long, a gangly skeleton of brass pipes and wooden scaffolding, mounted on the wheels of a Ford Model T. This strange machine, which rotated on its circular track once every 20 minutes, was nicknamed Jansky's merry-go-round. It was designed to be a direction finder, a sensitive ear that could pinpoint the origin of any radio interference. For months, Jansky patiently listened. He catalogued the familiar crackle and pop of distant thunderstorms, the shortwave interference from local electronics. He became a connoisseur of static, but beneath it all, one sound remained. A faint, ethereal hiss. It was weak, but it was maddeningly persistent, a whisper that refused to be silenced. At first, he suspected the sun the most powerful and obvious object in our celestial neighbourhood. But as he charted the noise, a strange pattern began to emerge. The hiss would rise and fall in intensity, but its cycle wasn't 24 hours, the time it takes for the Earth to turn relative to the sun. The peak of the signal arrived 4 minutes earlier each day. This small discrepancy was not a flaw in his equipment. It was the crucial clue. It was a fingerprint left at the scene of a cosmic mystery. You see, 4 minutes is the daily difference between solar time and zodiacal time, the time it takes for the Earth to rotate relative to the distant so-called fixed stars. This could mean only one thing, a conclusion so audacious, so far beyond the scope of his original assignment, that it must have felt like a dream. The noise wasn't coming from New York City. It wasn't coming from a storm over the Atlantic. It wasn't even coming from our own sun. The source of the static, the phantom hiss, plaguing Bell's telephone lines, was coming from beyond our solar system entirely. It was the voice of the Milky Way. Jansky had by complete accident opened a new window onto the universe. He had become the first human being to detect a radio signal from an extraterrestrial source, proving that the silent, serene heavens were anything but. They were alive with an invisible energy. He had stumbled upon a continent that no map had ever shown a landscape painted not in light, but in radio waves. Publishing his findings in 1933, Jansky pinpointed the loudest part of the signal toward the constellation of Sagittarius, a direction we now know points directly toward the turbulent supermassive black hole at the heart of our own galaxy. Yet the world barely noticed. His discovery was an answer to a question no one was asking. Astronomers who worked with glass lenses and photographic plates were ill-equipped to understand the implications. The public saw it as a scientific curiosity, a strange footnote in the annals of engineering. For almost a decade, this colossal discovery lay dormant. Carl Jansky, the father of a new science, went back to his engineering work at Bell Labs, his celestial static largely forgotten. The universe continued its silent roar, but humanity for a time had put its fingers back in its ears. The call went unanswered, but not unheard. In Wheaton, Illinois, a passionate amateur astronomer and engineer named Grote-Reber read Jansky's papers and was captivated. He saw what others had missed, not a nuisance but an epochal revelation. If the centre of our galaxy was broadcasting, what else might be out there in the deep, working alone in his backyard with his own funds? Reber decided he would build the world a proper ear. Throughout 1937, he constructed the world's first true radio telescope, a 9-metre parabolic dish, a steerable metal bowl designed to catch and focus the faint whispers from the cosmos. For years, through the lonely nights, Reber scanned the sky, meticulously charting the invisible landscape that Jansky had only glimpsed. He confirmed Jansky's findings, creating the first ever radio map of the Milky Way, a ghostly contour of our galaxy's hidden structure. But he also found something else. Away from the bright wash of the galactic plane, his telescope picked up isolated pockets of intense radio emission. They were discrete sources, cosmic lighthouses shining in the radio spectrum where the optical telescopes of the day saw little or nothing of interest. He labelled the brightest of these sources Cygnus A and Cassiopeia A. At the time, they were just points on a map, enigmatic beacons in the radio dark. No one could know that these were not just distant curiosities, they were monsters. The Second World War put a pause on this nascent science, but it also paradoxically provided the very tools that would unlock its future. The rapid development of radar technology created a generation of engineers and physicists who were masters of the radio spectrum. When peace returned, they turned their new powerful antennas away from enemy aircraft and pointed them toward the heavens. What they found would shatter our conception of the universe. With interferometry, the technique of linking multiple antennas to achieve breathtakingly sharp resolution, astronomers at Cambridge and Manchester began to resolve Reba's mysterious sources. They expected to see perhaps a strange star or a dense nebula. What they saw was utterly baffling. It was nonsensical. Take Cygnus A. When optical telescopes were finally aimed at its precise coordinates, they found a faint, distorted-looking galaxy some 600 million light-years away. It was peculiar, but not exceptionally so, in the Grand Galactic Zoo. But the radio image told a different terrifying story. The radio emission wasn't coming from the galaxy itself. The visible galaxy, a swirling city of 100 billion stars, was almost completely radio quiet. Instead, the source of this immense power originated from two colossal, entirely invisible structures that dwarfed the parent galaxy. Symmetrically placed on either side of it like two ghostly appendages were what came to be known as radio lobes. Imagine for a moment what this meant. Here was a galaxy, a vast island of stars and gas, and yet extending for hundreds of thousands of light years into the blackness of intergalactic space were two ethereal clouds invisible to any human eye that were pouring out more energy and radio waves than the entire galaxy was emitting in visible light. It was as if you saw a quiet candle flame and detected on either side of it two invisible blowtorches, each more powerful than a furnace. This broke all the rules. The energy source was clearly connected to the central galaxy, yet the energy was being deposited in regions far beyond its borders in the cold, empty void. How? How could a galaxy project its power across such vast distances to inflate these immense energetic phantoms? And the symmetry was a profound, tantalizing clue. This was not a random explosion, not a chaotic stellar cataclysm. The two lobes were often mirror images of one another, suggesting a process that was directed, focused, and terrifyingly stable over millions of years. It was as if something in the heart of that distant galaxy was acting like a cosmic cannon, firing unimaginable blasts of energy in two opposite directions. As more of these objects were found, the mystery only deepened. They came in all shapes and sizes. Some had long, narrow jets that seemed to feed the lobes, glowing tendrils of plasma arcing across the cosmos. Others had lobes that were bent and swept back as if the galaxy were ploughing through a celestial wind. They were given a name that captured their defining characteristic: radio galaxies. They were the loudest things in the universe, yet their power was almost entirely invisible. This was a new kind of cosmic behemoth, an entity that lived a double life. In one reality, the one we see with our eyes, it was a familiar collection of stars. In another, the hidden radio universe, it was an engine of unbelievable violence, painting the intergalactic medium with ghostly masterpieces of accelerated particles and magnetic fields. The central question became an obsession for a generation of astrophysicists. What conceivable object, what physical process could reside in the heart of a galaxy and power such a machine? It would need to be compact yet more powerful than 1 trillion suns. It would need to be a gravitational anchor, a central engine of almost unimaginable density and power. The hunt was on. The serene clockwork universe of Newton was gone. The elegant, expanding universe of Einstein and Hubble was proving to be far more complex and violent than they had ever imagined. The faint hiss recorded by Carl Jansky in a New Jersey field had become the first echo of a monstrous secret, a secret hidden in the cores of galaxies, waiting for us to finally build the eyes to see and the theories to understand. The celestial static was not noise. It was a message, a challenge posed by the cosmos itself. It was the sound of a hidden dragon sleeping in the dark heart of the night. The colossal ghostly lobes now had a definitive address. They were anchored, we knew, to that single shimmering point of light, the host galaxy, often hundreds of thousands of light years away. But this only sharpened the mystery, drawing the cosmic question mark into an infinitesimally small point right at the galactic centre. The scale of the problem was simply staggering. To inflate these structures to accelerate particles to within a hair's breadth of light speed and sustain that output for millions of years required an energy source that defied all conventional astrophysics. Summon the power of 100 billion stars like our Sun, and you would still fall short. Detonate a supernova every single day for eons, and you would barely begin to approach the required furnace. Something new was happening in the hearts of these galaxies, something violent, something impossibly efficient, something that operated on principles we were only just beginning to grasp. The technological key that unlocked the next door was resolution. By linking radio telescopes across continents, a technique known as very long baseline interferometry, we created virtual lenses the size of Earth, allowing us to zoom into those galactic cores with a precision that was previously the stuff of dreams. And as we peered into the deepest depths of galaxies like Cygnus A or M87, the faint, placid glow of their central stars gave way to a ferocious glare. At their very heart, we found a point source of emissions so compact it was barely resolvable, yet so brilliant it could outshine its entire host galaxy of billions of stars. This was no mere collection of stars. It was a celestial blast furnace, a seething, spitting cauldron of energy that flickered and flared on timescales of weeks, days, even hours. This rapid variability was a crucial clue, a cosmic fingerprint. For an object to change its brightness so quickly, it had to be small. Light, after all, has a speed limit. If a source a light year across were to flare up, it would take a full year for the change to propagate across its face. The flickering we observed meant this engine had to be contained within a volume no larger than our own solar system. An entire galaxy's worth of power squeezed into a space that would barely contain the orbit of Neptune. Astrophysicists had a name for this phenomenon, a label for the bewildering physics unfolding at these galactic centers. They called it an active galactic nucleus, or AGN. It was a clinical, almost sterile term for what was in reality the most violent and luminous sustained event in the known universe. But giving it a name did not solve the riddle. What could possibly generate this much energy in such a small space? The first ideas were like grasping in the dark. Perhaps some speculated it was a superstar, a hypothetical object, 1,000,000 times more massive than our Sun, burning through its fuel at an unimaginable rate before collapsing under its own prodigious weight. Others imagined hyperdense star clusters, where stars collided and merged in a constant chaotic demolition, Derby releasing immense bursts of energy with every cataclysmic impact. These were brilliant creative attempts to explain the inexplicable using the physics we understood. But they all had a fatal flaw. They weren't efficient enough. They couldn't sustain the output for the millions of years the radio lobes told us they must. They burned out too fast like cosmic flashbulbs, whereas the evidence pointed to a powerhouse, a celestial generator that could run for entire geological ages. The answer, when it was finally proposed in the 1960s by minds like Yakov Zeldovich, Edwin Salpeter and Donald Lyndon Bell, was not just an evolution of existing ideas. It was a radical, terrifying and almost philosophical leap into a new realm of physics. It was a concept born from the most extreme predictions of Einstein's theory of general relativity. An idea so strange, so seemingly paradoxical, that many in the scientific community initially recoiled. They proposed that the engine at the heart of every AGN, the ultimate power source for these cosmic behemoths, was a black hole. Not just any black hole, not the kind left over from a single dead star. They envisioned something on a completely different scale of being. A supermassive black hole, a gravitational singularity millions or even billions of times the mass of our Sun compressed into a point of infinite density. This was a monster hiding in the dark, a gravitational well so profound that nothing, not even light, could escape once it crossed the point of no return, the event horizon. And right there was the screaming paradox that made the theory so hard to swallow. Black holes were famous for one thing they consumed. They were the universe's ultimate endpoint cosmic prisons from which there was no parole. How then could the universe's greatest taker also be its most prolific giver of energy? How could an object defined by its ability to pull things be responsible for launching twin jets of matter out at 99.9% the speed of light? It seemed like a fundamental contradiction, a violation of its very nature. The solution to this profound puzzle was not in the black hole itself, but in the chaos it orchestrates just outside its grasp. Imagine a vast, rotating cloud of gas dust and shredded stars, the accumulated debris of millions of years of galactic life drawn inexorably inward by the monster's pull. As this material spirals closer, it cannot simply fall straight in. Conservation of angular momentum, the same principle that keeps a figure skater spinning faster, as she pulls in her arms, forces the doomed matter into a flattened spinning disk. This is the accretion disk, and it is one of the most violent and energetic structures in creation. It is not a gentle whirlpool, it is a gravitational grinding mill. As gas and dust orbit within the disk, moving at relativistic speeds, different layers rub against each other with unimaginable friction. This cosmic friction, this shearing of space-time itself, generates heat on a scale that beggars belief. The inner edge of the disk, just before matter takes its final plunge across the event horizon, can reach temperatures of millions, even tens of millions of degrees. Hotter than the core of the most massive star, so hot that atoms are stripped bare, their electrons torn away, forming a swirling soup of magnetized plasma. This plasma doesn't just glow, it blazes. It unleashes a torrent of radiation across the entire electromagnetic spectrum, from low-energy radio waves to the most energetic gamma rays. This, we realized, was the source of the AGN's brilliant light. It wasn't the black hole itself that we were seeing. You can never see a black hole. It was the tortured, incandescent death scream of matter in its final moments before annihilation. The accretion disk solved the first part of the mystery, the source of the incredible luminosity. Here was a mechanism of sublime efficiency, capable of converting up to 40% of the mass of infalling matter directly into energy as described by EMC2. For comparison, nuclear fusion, the engine that powers our sun, converts less than 1%. This was the powerhouse the theorists had been looking for, a machine that could outshine 100 billion stars for eons, fueled by a steady diet of interstellar gas. But it still didn't explain the jets. The light from the disk was isotropic. It shone out in all directions. The radio jets, however, were anything but. They were tightly focused, collimated beams fired with the precision of a cosmic sniper from the north and south poles of the system. The accretion disk was the furnace, but what was the nozzle? What mechanism could take the chaotic energy of this swirling disk and channel it into two perfectly opposing light-speed conduits? The answer, it turned out, was a dance between gravity magnetism and the most bizarre prediction of Einstein's theory that a spinning black hole doesn't just curve space-time, it twists it. It drags the very fabric of the universe around with it, a phenomenon known as frame dragging. Now picture that superheated, magnetized plasma in the accretion disk. The magnetic field lines generated by the churning plasma are initially chaotic, but as they are swept close to the spinning black hole, they're ensnared by its twisting space-time. The black hole acts like a colossal cosmic dynamo. Its rotation, its frame dragging, grabs hold of these magnetic field lines and twists them into two tightly wound monumental funnels emanating from its poles. It's a process of unimaginable power, elegantly described by theorists Roger Blandford and Roman Znayak. This rapidly rotating, magnetized funnel becomes the universe's most perfect particle accelerator. Some of the charged particles from the inner edge of the accretion disk, instead of falling into the black hole, are caught by these magnetic funnels. They are seized confined and then propelled outwards along this magnetic highway. As they are flung away from the black hole's poles, they are accelerated relentlessly, stealing rotational energy directly from the black hole itself. The supermassive black hole in this sense is not just a passive consumer, it is an active gravitational gyroscope, a spinning engine that converts its own rotational momentum into the kinetic energy of the jets. These aren't gentle stellar winds, this is a celestial blowtorch. A continuous focused beam of plasma moving at such extreme velocity that its journey across hundreds of thousands of light years is for the particles themselves a nearly instantaneous flash. The paradox was solved. The black hole doesn't produce the jets directly. Instead, its immense gravity creates the accretion disk, the fuel and the furnace, and its powerful spin twists magnetic fields into the nozzle, the accelerator that launches the resulting plasma across intergalactic space. It is a system of breathtaking synergy, where the act of consumption directly fuels the mechanism of expulsion. The greatest gravitational pull in the universe through this exquisite cosmic judo becomes the source of the universe's most powerful push. This was a magnificent, all-encompassing theory. It explained the energy, the luminosity, the compact size, and even the very existence of the jets. But a theory, no matter how beautiful, is just a story without evidence. The hunt was now on to find observational proof to catch these systems in the act and confirm the wild predictions of the model. If the model were true, what would we expect to see? We would expect to see the spectral fingerprints of gas moving at incredible speeds. As we pointed our spectrographs at the hearts of these active galaxies, that is precisely what we found. The light was smeared out into broad emission lines, a classic Doppler signature of gas clouds, orbiting a central object at thousands of kilometers per second. Only the gravitational command of a billion solar mass object could force matter to move with such ferocious velocity. We would expect to trace the jets all the way back to their source, and as our interferometers grew ever more powerful, we did. We could see the jets, these impossibly thin tendrils of light and energy, emerging from an unresolved point at the very centre of the galaxy, confirming their origin with a precision that was simply undeniable. We could even see blobs of plasma moving outwards within the jets at apparent superluminal speeds, an illusion created by their near light speed motion, but a powerful confirmation of the relativistic velocities involved. One by one, the pieces of the puzzle fell into place. The observations matched the theory with stunning fidelity. The monster in the dark was no longer a ghost, a spectre of theory. It had a name, a supermassive black hole. It had a mechanism, the accretion disk. It had a blueprint for its awesome power, the twisting of space-time itself. The evidence was overwhelming, and a paradigm shift rippled through the world of astronomy. These radio galaxies were not just strange celestial oddities. They were laboratories for extreme physics windows into a universe where gravity reigned supreme in ways we had never imagined. We had found the engine, but this profound revelation only opened up a new vista of questions. Was every galaxy hiding one of these titans in its core? What role did they play in the evolution of the galaxies they inhabit? Are they creators as well as destroyers? To truly know the monster, to fully grasp its power, we would need to do more than just study its brilliant handiwork. We would have to get closer. We would have to find a way to stare directly into its heart to see the unseeable and capture the shadow of the beast itself. It would be an act of supreme cosmic audacity, an observational challenge that would require a telescope not built of glass and steel, but forged from the diameter of our entire planet, and so the puzzle lay exposed on the cosmic table. The evidence was maddeningly incomplete, a celestial crime scene with a victim of unimaginable scale, but no weapon, no perpetrator, only a faint whisper from the galactic core. For decades, astronomers stared at these bifurcated ghosts, these colossal radio lobes flanking an otherwise unremarkable point of light, and were forced to confront a profound disconnect. The energy required to inflate these structures to push them out into the void over millions of years was simply staggering, dwarfing the output of all the stars in the host galaxy combined. Yet the engine responsible remained completely invisible, shrouded in mystery, its power transmitted across hundreds of thousands of light years by means we could only guess at. Theories swirled like nebular dust chains of supernovae, exotic stellar remnants, but none could adequately explain the sheer relentless power or the perfect terrifying symmetry. Science had reached an impasse armed with a beautiful and frustrating paradox. It was a paradox that could only be broken by a fundamentally new way of seeing. That new vision would not come from a larger lens or a more polished mirror, but from an army of steel giants rising from the high desert plains of New Mexico. The answer, when it arrived, was etched not in light, but in the longest wavelengths of the electromagnetic spectrum captured by the 27 colossal dishes of the Carl G. Jansky Very Large Array. Stretched across the plains of San Agustin, this was not merely a telescope. It was a revolution in perspective, a synthetic eye the size of a city. By combining the signals from each of its 230-ton antennas, a technique called interferometry, the VLA could achieve a resolution so fine it was like standing in New York City and being able to read the headline of a newspaper in Los Angeles. For the first time, we had the power to zoom in on the enigmatic hearts of those distant radio galaxies, to peer directly into the space between the galaxy and its ghostly lobes. What we found there in the first flood of crystalline data was the missing link, the murder weapon we had been searching for all along. It was a structure more bizarre, more powerful and more elegant than we had ever dared to imagine. Emerging from the infinitesimal galactic core, the VLA revealed them impossibly thin, perfectly straight filaments of energy. They were ethereal bridges of plasma, luminous threads connecting the central engine to the distant billowing lobes. We call them relativistic jets. The name is an understatement of cosmic proportions. These are not merely streams of hot gas. They are cosmic fire hoses driven by physics at its most extreme. Matter superheated into a plasma state is captured, accelerated and fired out into the void at speeds exceeding 99% of the speed of light. Imagine a particle accelerator, not built in a subterranean tunnel, but one powered by the geometry of space-time itself, a machine whose components are magnetic fields and gravity. This is what we were witnessing. The jets were the conduits, the physical mechanism that transported the unfathomable energy of the core outwards, punching through the galaxy's own interstellar medium and slamming into the tenuous gas that lies between the galaxies. The lobes, those radio-bright phantoms we'd seen for so long, were finally explained. They were not the source of the emission, but the consequence of it. The accumulated wreckage, the cosmic splash zone where these relentless jets terminate their journey, shocking the surrounding medium into a radio-bright frenzy. The sheer precision of these structures is almost unnerving. We saw jets that maintained their needle-like focus, a perfectly collimated beam, over distances of millions of light years. This is a feat of natural engineering that beggars belief. It is equivalent to a laser pointer on Earth maintaining a beam no wider than a dinner plate all the way to the moon. Whatever mechanism was launching these jets was not just powerful, it was a gravitational gyroscope of incomprehensible stability, operating flawlessly over geological timescales. Observing these jets for the first time was a watershed moment, the kind of discovery that cleaves scientific history into a before and an after. Before we had a collection of strange phenomena. After we had a unified physical system. The lobes were the exhaust clouds, the galaxy was the chassis, but now finally we could see the roaring twin pipes of the engine itself. But this revelation, as profound as it was, only deepened the central mystery. An engine capable of launching such structures had to be something truly extraordinary. It had to be compact, unimaginably massive, and capable of converting matter into energy with an efficiency that would make nuclear fusion look like a flickering candle. There was only one known object in the universe that fit such a terrifying and magnificent description. The VLA had given us the anatomy of the beast, but to understand its heart we needed to look with different eyes. We turned to orbit to the unblinking gaze of the Hubble Space Telescope. Where radio waves showed us the raw power, Hubble's exquisite vision operating in visible and ultraviolet light provided the context. It peeled back the curtains of distance, revealing the host galaxies themselves in breathtaking detail. We saw that these radio-loud behemoths were not quiet, orderly spirals like our own Milky Way. More often than not, they were chaotic, violent ellipticals, galactic titans still reeling from recent cataclysmic mergers with other galaxies. Hubble's images were portraits of cosmic trauma, swirling dust lanes, tidal tales of orphaned stars and multiple disturbed nuclei. This was crucial. These galactic train wrecks provided a constant fresh supply of fuel gas dust and shredded stars cascading towards the galactic center. They were the perfect feeding grounds for a monster. Hubble pinpointed the exact central point of these chaotic systems, the precise origin of the radio jets, a single brilliant point of light, often outshining all the billions of surrounding stars. It was a quasar, the hyperluminous signature of matter being consumed under the most extreme conditions imaginable. Yet even Hubble could not see the engine itself. The final piece of incontrovertible evidence required us to pierce the veil of gas and dust with even more energetic light. We needed to see the universe in X-rays, the spectrum of violence. This was the mission of the Chandra X-ray Observatory. When Chandra turned its specialized mirrors towards these galactic cores, it revealed a spectacle of pure chaos. It saw what lay hidden just outside the point of no return, the accretion disk. This is the final staging ground for matter doomed to fall into the central object. Here, gas and dust don't fall straight in. They are caught in a gravitational whirlpool, a flattened spinning disk of material being whipped around the central engine at incredible speeds. The friction within this disk, the shearing of atoms against atoms, heats the material to millions of degrees, causing it to glow fiercely, not in visible light, but in high-energy X-rays. Chandra saw this incandescent, shrieking disk of superheated plasma, the death spiral of matter giving off one last brilliant burst of energy before it vanished forever. This was the fuel tank and the ignition system all in one. The sheer luminosity in the X-ray spectrum was a direct measure of the rate at which the engine was feeding. The numbers were astronomical, confirming that these objects were consuming matter at a rate of several suns per year. Chandra's vision extended even further, tracing the jets themselves. It detected X-ray hotspots along their length knots of intensely bright emission, called synchrotron radiation, produced as electrons spiral around the jet's powerful magnetic fields at nearly the speed of light. This was a direct confirmation of the physics at play, a temperature reading from the barrel of the cosmic gun. And where the jets terminated, Chandra saw vast bow-shaped shockwaves, immense shells of gas heated to tens of millions of degrees, glowing brightly in X-rays. This was the heat of impact, the kinetic energy of the jet being violently converted into thermal energy, perfectly corroborating the radio observations of the lobes. The multi-wavelength picture was now complete and undeniable. The radio telescopes showed us the jet's magnetic structure. The optical telescopes showed us the chaotic, fuel-rich environment. And the X-ray telescopes showed us the superheated, tortured matter of the accretion disk itself. All lines of evidence from every part of the spectrum were pointing to one single inescapable conclusion. They were pointing to a supermassive black hole. Here at last, the hypothesis that had been whispered for years was transformed into an established scientific paradigm. The supermassive black hole was no longer just a compelling theory. It was the only explanation that fit all the facts. It is the perfect engine for a radio galaxy. Its immense gravity is the anchor, the central organizing principle that captures and funnels the fuel provided by galactic mergers. The infalling material forms the accretion disk, the brilliant X-ray bright furnace that converts gravitational potential energy into radiation with terrifying efficiency. But it's the black hole's spin its rotation that acts as the ultimate cosmic flywheel. As it spins, it twists the fabric of space-time around it, and in doing so, it drags the magnetic fields embedded within the accretion disk along for the ride. These magnetic fields, now wound up into tight helical structures, become a colossal electromagnetic cannon. They tap into the rotational energy of the black hole itself, grabbing charged particles from the inner edge of the accretion disk and flinging them outwards along the black hole's poles of rotation away from the choking plane of the disk. This is the launch mechanism. A fraction of the matter destined for oblivion is saved at the last moment, and repurposed, ejected in two perfectly opposing, tightly collimated jets that travel for eons across the cosmos. We had finally unmasked the ghost in the machine. The phantom energy source that had perplexed astronomers for half a century was the most extreme object permitted by the laws of physics. It is an engine that feeds on destruction to build structures larger than the galaxy that hosts it. It is a testament to the universe's ability to create order and structure out of pure chaos. To stand in the path of one of these jets would be to witness the ultimate annihilation. You would be vaporized by a torrent of gamma rays and high-energy particles traveling so close to the speed of light that from their perspective time would barely pass on their journey from the galactic core to the outer lobes. The sheer scale of the energy release is difficult for the human mind to process. The power radiated by a single bright radio galaxy just through its jets and lobes can be more than 1 trillion times the luminosity of our sun. That energy is pumped continuously for tens of millions of years. The lobes of the largest known radio galaxy, Alcyone, stretch for over 16 million light-years, a structure more than 150 times the diameter of our own Milky Way, all built by two relentless streams of particles launched from a region of space smaller than our solar system. This discovery did more than just solve the riddle of the radio galaxies. It fundamentally changed our understanding of the universe itself. We realised that these supermassive black holes are not merely passive sinkholes, cosmic oddities sitting quietly at the centres of galaxies. They are active, powerful agents of cosmic change. They are architects of cosmic structure, intricately linked to the life and death of the very galaxies they inhabit. The confirmation of the black hole engine was not an end to the story, but a dramatic turning point. It closed one chapter of mystery only to open another far grander one. We now knew what they were and, in principle, how they worked. But a new set of questions with even more profound implications began to emerge from the data. If these jets are pumping such colossal amounts of energy into the space around them, what effect does that have on the galaxy itself? How does this violent feedback from the central engine regulate the birth of new stars? How do these celestial blowtorches enrich the intergalactic medium with heavy elements forged in the accretion disk? We had found the engine, yes, but now we had to confront the astonishing consequences of its existence to understand how these loud, luminous monsters don't just occupy the universe, but actively sculpt it. But the story of this gravitational heart, this singularity spinning space-time into a furious engine, does not end in the blinding glare of the galactic core. Its true legacy is written across millions of light years, not in light, but in violence and in shadow. The colossal jets we have witnessed erupting from the black hole's poles are not merely ethereal beams of light. They are tangible kinetic weapons of almost unimaginable power, fired into the cosmos. They are celestial arteries pumping the ferocious energy of the central engine out into the vast dark territories that lie between the galaxies. To understand their impact is to understand that a single supermassive black hole can hold an entire cluster of galaxies hostage, dictating the course of its evolution for billions of years. This is the downward path of its power, a journey from the infinitely small to the incomprehensibly large, where the jets become cosmic sculptors and their canvas is the universe itself. Imagine leaving the confines of the host galaxy, travelling outwards into what we perceive as the perfect emptiness of intergalactic space. It is not truly empty. Surrounding every galaxy and filling the immense voids within every galaxy cluster is a ghostly ocean of superheated, ionized gas. This is the intracluster medium, a vast, nearly invisible atmosphere of hydrogen and helium atoms so diffuse that a cubic meter contains only a few particles. Yet across the span of 1 million light-years, this tenuous medium contains more normal matter, more baryonic mass than all the stars in all the galaxies of the cluster combined. For eons, this colossal reservoir of gas has been slowly cooling under its own gravity, a cosmic rain cloud preparing to collapse inward, destined to seed the galaxies within it with fresh fuel for a brilliant new generation of stars. Left to its own devices, this process would have created galaxies far larger and more luminous than anything we observe in the local universe. But they are not left to their own devices. Into this serene, cooling ocean, the radio galaxy unleashes its twin lances of annihilation. The jets, travelling at a significant fraction of the speed of light, are like solid pistons ramming into a placid lake. They don't just pass through the gas, they tear it asunder. A supersonic shockwave, a cosmic tsunami of pressure and heat precedes the jet's advance. It ploughs through the intracluster medium, violently compressing the gas in its path, while simultaneously heating it to millions of degrees Kelvin. The kinetic energy of the particles in the jet, the raw momentum of their relativistic flight, is transferred directly into the thermal energy of this cosmic atmosphere. The gentle, slow process of cooling is instantly and brutally reversed. The galactic rain cloud is boiled away before it can ever fall. This monumental process is known as feedback, and it is one of the most profound and essential forces shaping the universe as we see it today. The supermassive black hole in the act of feeding effectively chokes off its own future food supply and that of its entire galactic neighbourhood. It acts as a galactic thermostat. As gas cools and flows toward the central galaxy, it fuels the accretion disk, which in turn powers the jets. The jets then blast out and reheat the surrounding gas, stopping the inflow. The engine starves, the jets flicker and die. Gravity then takes over once more, and the gas begins its slow, cooling process, all over again until it eventually reaches the black hole and awakens the beast, restarting the entire cycle. This cosmic conversation, a violent dialogue between the black hole and its environment, can repeat over and over for billions of years. It is the reason why the largest galaxies in the universe stopped growing, why they are not the runaway behemoths that our simplest models would predict. They are self-limiting systems forever regulated by the monster at their heart. We do not have to guess that this is happening. We can see the evidence carved into the sky. When we turn our X-ray telescopes like the Chandra X-ray Observatory toward a galaxy cluster dominated by a radio galaxy, we are not looking for the jets themselves, which are often invisible at these wavelengths. Instead, we are looking at the ghostly ocean of the intracluster medium, which being heated to millions of degrees glows brightly in X-ray light. And within this smooth, luminous glow we find something astonishing: vast, dark cavities. Immense bubbles of emptiness, sometimes larger than the entire galaxies, pushed into the hot gas. These are the scars left behind by the jets. They are the footprints of the monster. For millions of years, the jets inflated these cosmic balloons, pushing aside the hot X-ray emitting gas and filling the void with their own cargo of high-energy particles and magnetic fields. We see them as cosmic voids, a direct physical record of the energy being pumped into the system. These are not static relics. The inflation of these bubbles is an explosive event that sends ripples, quite literally sound waves, propagating through the cluster's atmosphere. These are the deepest and most powerful sound waves in the universe, a B-flat some 57 octaves below, middle C completely inaudible to the human ear, but carrying enough energy to heat the gas for hundreds of thousands of light years in every direction. We can trace these faint ripples in the X-ray images, pressure waves expanding outward from the central galaxy, each one a testament to a past eruption from the central engine. It is the sound of the black hole clearing its throat, a deep resonant hum, that prevents the cosmic gas from ever truly settling down, from ever forming the torrent of stars that gravity so desperately wants to create. The jets, even long after they have vanished, leave behind an echo of their power that shapes the destiny of the entire cluster. But here, as is so often the case in cosmology, the story takes a fascinating and contradictory turn. While this powerful feedback mechanism is overwhelmingly suppressive, a great cosmic off switch for star formation. Under the right circumstances, it can become the exact opposite. The jets are not subtle. Their power is not applied gently or uniformly. The same shockwave that heats the vast diffuse ocean of the intracluster medium can have a profoundly different effect on a small dense cloud of cold molecular gas it happens to encounter. Imagine the jet as a cosmic snowplow. While it clears the main highway of thin powdery snow, if it slams into a dense wet snowbank it doesn't disperse it. It compresses it, packing it tighter and tighter. In the same way, when the jet's shockwave encounters a dense pocket of interstellar gas, the sudden violent compression can be the final push needed to trigger gravitational collapse. The shockwave squeezes the cloud, pushing its density past a critical threshold, the point of no return where its own gravity takes over, and it begins to fragment and collapse into a flurry of protostars. This is called positive feedback or jet-induced star formation. We see tantalizing evidence for this throughout the universe. Lines of young, brilliant blue stars arranged perfectly along the trajectory of a radio jet like pearls on a string. It is a beautiful paradox. The very same cataclysmic outflow that sterilizes a galaxy on a grand scale can at the local level become a stellar nursery. It is an engine of both creation and destruction, a force that gives with one hand while taking away with the other. The black hole in its fury can sometimes sculpt the very stars that will one day illuminate its domain, a complex and unpredictable dance of cosmic energies that challenges our simple narratives of galactic evolution. A radio galaxy is not just a killer of star formation, it is a redistributor of it, choosing where and when new suns will be born. This duality of behaviour, this ability to be both a precise weapon and a blunt instrument, hinted that not all radio galaxies were created equal. As astronomers catalogued more and more of these cosmic behemoths in the 1970s, a pattern began to emerge, a fundamental division in their very structure. Two scientists, Bernard Fanaroff and Julia Riley, noticed that radio galaxies seem to fall into two distinct morphological classes, a classification scheme that has become a cornerstone of extragalactic astronomy. They are known with scientific simplicity as Fanneroff-Riley Class 1 and Class 2, or more simply FR1 and FR2. Though separated by a simple Roman numeral, they represent two profoundly different ways for a black hole to interact with its environment. The FR2 radio galaxies are the archetypal image that comes to mind. They are the cosmic snipers. Their jets are remarkably powerful, highly relativistic, and incredibly well collimated. They act like laser beams punching cleanly through the interstellar medium of their host galaxy and travelling in a nearly straight line for hundreds of thousands, sometimes millions of light years into the sparse territory of intergalactic space. Because they maintain their speed and focus over these vast distances, they deposit the bulk of their energy very far from their galactic home. The jet remains a narrow, almost invisible line until it finally slams into the ambient gas of the intracluenster medium. At this point of impact, it creates a brilliant compact knot of energy known as a hotspot. This is a terminal shockwave of immense power, a place where the jet's kinetic energy is explosively converted into radiation. Trailing behind these hotspots are the vast, billowing radio lobes, plumes of energetic particles and magnetic fields that are inflated by the continuous outflow from the jet. When you look at an FR2 in a radio telescope, you see a bright central core, two faint thread-like jets, and two intensely bright hotspots at the far edges of two colossal ghostly lobes. They are edge-brightened, their power delivered with surgical precision at the farthest possible reach. FR1 galaxies, by contrast, are the cosmic flamethrowers. They are generally less powerful, their jets less relativistic and more turbulent. Instead of punching cleanly through their host galaxy's atmosphere, they begin to interact with it much closer to home. The jets are disrupted, they slow down, and they flare out, becoming broader and more diffuse. They lose their tight collimation and spread their energy over a much wider area much nearer to the central engine. As a result, they lack the distinct brilliant hotspots of their FR2 cousins. Their radio lobes are not edge-brightened, but rather fade away more gently brightest near the core and becoming fainter with distance. They look less like a sniper rifle's precise shot, and more like the billowing, chaotic plume from a powerful fire. The lobes are often bent and distorted by the motion of the galaxy through the intracluster medium, creating spectacular wide-angle tail or narrow-angle tail structures that look like cosmic smoke trails marking the galaxy's path. This fundamental difference between the sniper and the flamethrower is not just a matter of aesthetics, it is deeply tied to the feedback mechanisms we have explored. An FR2 with its highly focused jets is incredibly effective at drilling deep into the heart of a galaxy cluster and depositing energy far from the central galaxy. It inflates those giant X-ray cavities and sends powerful sound waves rippling through the entire cluster, providing a powerful albeit episodic heating mechanism for the entire environment. It is a tool for cosmological regulation. An FRY, on the other hand, deposits its energy much closer to home. Its messy, turbulent plumes stir and heat the gas in the immediate vicinity of the host galaxy, a process sometimes called radio-mechanical feedback. This might provide a more gentle, more continuous simmering of the galactic atmosphere, preventing cooling in a less dramatic but perhaps more persistent fashion. The universe, it seems, has developed multiple ways for black holes to communicate their displeasure, from the precise long-range strike to the close-quarters wide-area blast. Understanding this division allows us to see how the cosmic web itself is sculpted. These jets are not isolated phenomena. They are integral players in the grand architecture of the cosmos. The filaments of the cosmic web, those great highways of dark matter and gas that connect clusters of galaxies, are the ultimate source of fuel for galaxy growth. As gas flows along these filaments and into the deep gravity wells of clusters, it should in theory cool and create a runaway cascade of star formation. The fact that it doesn't is in large part due to the persistent ongoing work of these radio jets. They are the feedback agents on a cosmological scale, heating the gas within clusters and along the filaments, enriching it with heavy elements forged in their host galaxies and magnetizing it with the fields they drag outwards. They are the gatekeepers of the cosmic web, fundamentally altering the thermal state and chemical composition of the very material from which all future galaxies will be born. the silent, screaming whispers of a radio galaxy are in a very real sense the sound of the universe building itself a constant negotiation between the inexorable pull of gravity and the explosive fury of the singularity. We have witnessed their power to shape entire galaxies to govern the life and death of stars on a scale that defies easy comprehension. We have classified their methods of destruction, separating the precise strike from the chaotic blast. But this raises a deeper, more fundamental question. The jets are the consequence, the effect of the central engine. What then fuels the engine itself? What is the trigger that awakens a dormant supermassive black hole and transforms a quiet normal galaxy into one of these universe-altering beacons? The downward path of power is clear, but we must now turn our gaze back to the source to understand the cataclysmic events that can throw a galaxy, and indeed an entire cosmic neighbourhood, into turmoil and ignite the loudest objects in the universe. Undefined. We have journeyed across millions of light years tracing these ethereal structures of incandescent plasma back to their singular violent origin. We have witnessed their lobes bloom like ghostly flowers in the intergalactic dark, dwarfing the very galaxies that gave them birth. Now we must take the final perilous step. We stand at the precipice of the engine room itself, a realm smaller than our own solar system that wields the power of 1 trillion suns. This is a place where space and time are not merely bent, but violently twisted, where the laws of physics are pushed to their absolute shrieking limit, and where matter is forged into a weapon of cosmic scale. The question that has haunted us throughout our journey now demands an answer. How does a gravitational abyss, an object defined by its inability to let anything escape, become the universe's most prodigious fountain? The secret lies not just in the black hole itself, but in the chaotic, swirling symphony of matter energy and magnetism that performs its deadly ballet around the event horizon. The stage for this cataclysm is the accretion disk, that spinning platter of doomed material we've seen before, but to see it merely as a fuel source is to profoundly misunderstand its role. It is not a passive conveyor belt of gas and dust. It is a celestial sawmill, a place of unimaginable friction and violence, where entire stars are shredded into streams of superheated plasma. As this material spirals inward, accelerated by the black hole's gravity, it heats to millions of degrees, glowing fiercely in X-rays. Yet more important than this heat is the magnetic field it carries. Every star, every gas cloud that falls into this maelstrom brings with it its own magnetic signature. The disk's furious differential rotation, with its inner edge spinning far faster than its outer rim, takes these countless tangled magnetic fields and organizes them. It acts like a cosmic dynamo, stretching, twisting and amplifying these fields into a colossal, ordered structure. Imagine countless threads being spun into a single, impossibly strong rope. This process creates a towering, vertical magnetic field that erupts from the disk's surface perpendicular to the plane of its rotation. These field lines, now anchored in the rapidly orbiting plasma, form a magnetic cage around the central black hole, a funnel of immense power pointing away from the abyss. This is the scaffolding, the launch pad for the jets. But the scaffolding alone has no power. It needs an engine to electrify it, a prime mover to pour energy into its structure. And for that we must look even closer into a region of pure gravitational distortion, to the spinning heart of the monster itself. Not all supermassive black holes are created equal. Like planets or stars, they can spin, and for the engines of radio galaxies this spin is not an incidental property. It is the fundamental source of their power. A spinning black hole performs a truly bizarre act of cosmic vandalism. It does not merely warp the space-time around it, it actively drags the very fabric of reality along with its rotation. This phenomenon, predicted by Einstein's equations and known as frame dragging, creates a vortex of space-time. Just outside the event horizon of a spinning black hole lies a surreal region called the ergosphere. Within this zone, space-time is being dragged faster than the local speed of light. Nothing, not even light itself, can stand still here relative to a distant observer. You're inexorably forced to co-rotate with the black hole. To enter the ergosphere is to be caught in a gravitational whirlpool from which there is no escape save for falling into the event horizon. It is a no man's land between the outer universe and the point of no return. And it is here in this realm of twisted reality that the universe found a way to tap the black hole's near-limitless rotational energy. This is the conceptual breakthrough that began to finally unravel the mystery of the jets. The black hole isn't just a drain, it's a colossal flywheel storing mind-boggling quantities of energy in its spin energy that can, under the right conditions, be extracted. The most compelling explanation for how this theft is accomplished is a breathtakingly elegant and violent mechanism proposed by theorists Roger Blandford and Roman Znayak. The Blandford-Znayak process is nothing less than a recipe for wringing energy from the spinning void. It begins with those powerful magnetic field lines generated by the accretion disk. Some of these lines do not simply end in space, they thread directly through the black hole's ergosphere, piercing the space-time vortex itself. Imagine those lines as immensely strong conductive wires. As the black hole spins, its frame-dragging effect grabs these magnetic field lines and twists them with unimaginable force, like a child winding up a rubber band on a toy airplane. This titanic twisting generates colossal electric currents and a voltage difference between the black hole's poles and its equator that can exceed 10 quintillion volts. The ergosphere is transformed into the universe's largest electric generator. This is the crucial link. The rotational kinetic energy of the black hole is being directly converted into pure electromagnetic power. At the poles, where the twisting is most extreme, this magnetic tension builds to a breaking point. It creates a tightly wound, highly pressurized channel, a magnetic nozzle aimed directly away from the black hole. All that is needed now is something to accelerate. Particles from the inner edge of the accretion disk electrons and their antimatter counterparts positrons, forged in the intense radiation, are fed into the base of this magnetic nozzle. Once caught in this channel, they are seized by the ferocious electromagnetic fields. They are no longer subject to mere gravity. They are now riding a wave of pure power, an electromagnetic slingshot powered by the rotation of space-time. They are accelerated outward along the black hole's spin axis, away from the abyss, at speeds exceeding 99.99% of the speed of light. The process is a masterpiece of cosmic efficiency, converting the black hole's spin into a pair of perfectly opposing, tightly collimated beams of relativistic plasma. This is the birth of the jets. We are witnessing a gravitational gyroscope transforming itself into a particle accelerator. A fraction of the matter falling toward the black hole provides the magnetic architecture, but the prodigious energy that inflates the giant radio lobes millions of light years away is stolen directly from the spin of the singularity. The black hole is in effect powering down over billions of years, its rotational energy being steadily drained to fuel these colossal cosmic blowtorches. The ghost in the machine is not just gravity, but the potent and often overlooked force of electromagnetism, organized on a scale that beggars belief and powered by the most extreme physics in the cosmos. But creating a beam of fast-moving particles is only part of the story. The radio in Radio Galaxy comes from a specific kind of light, a ghostly emission that tells a tale of incredible energies. As these electrons and positrons are fired out of the central engine, they are still trapped, spiraling furiously around the magnetic field lines that both accelerate and confine them. A charged particle moving in a straight line is quiet, but force it to turn to follow a curved path and it screams. It bleeds energy in the form of electromagnetic radiation. When that particle is an electron moving at nearly the speed of light, and the force compelling it to spiral is an intense magnetic field that screams a powerful polarized radio wave known as synchrotron radiation. This is the light our radio telescopes see. It is the signature of relativistic electrons being whipped around magnetic field lines. Every photon captured from these vast jets and lobes is a testament to a single electron being violently constrained on its journey. The jets themselves become vast luminous structures, not because the plasma is necessarily hot in the traditional sense, but because it is a near-perfect environment for generating this specific type of light. The entire structure from the core to the distant lobes is painted for us in the sky by the synchrotron glow of its constituent particles. Furthermore, the journey of this plasma is far from smooth. As the jet punches its way out of the host galaxy and into the tenuous gas of the intergalactic medium, It creates a series of shock waves, cosmic sonic booms that ripple through the beam. At these shock fronts, particles can be accelerated again and again, bounced back and forth across the shock boundary, like cosmic ping-pong balls gaining energy with each traversal. This process, known as shock acceleration, can boost a small fraction of the particles to truly extraordinary energies, making them responsible for the brightest knots and hotspots we observe within the jets. These are the locations where the beam's energy is being most violently dissipated, where it collides with itself or with the surrounding medium, creating regions of intense particle acceleration and brilliant synchrotron emission. The beautiful, complex and often knotted structure of the jets we see is therefore a living record of their violent history, a map of the shocks and instabilities they have encountered over millions of years. It tells a story of a relentless battle between the outward push of the beam and the confining pressure of the gas that fills the void between galaxies. The jet is not merely coasting through space. It is a dynamic, self-sustaining entity continuously re-energizing itself as it propagates across the cosmos. One of the most profound and persistent mysteries is how these jets remain so incredibly straight and narrow. Some can travel for millions of light years and maintain a width that is a tiny fraction of their length, a degree of collimation that defies easy explanation. A simple blast of hot gas would dissipate and spread out almost immediately. The answer, we believe, lies once again with magnetism. The jet is not a naked beam of particles. It is sheathed in a powerful helically wound magnetic field, the same field that helped launch it. This magnetic sheath acts like a flexible invisible pipe, a sort of cosmic scabbard, that confines the high-energy plasma within it and prevents it from mixing with the surrounding medium. It provides a magnetic hoop stress, an inward pressure that balances the outward pressure of the relativistic particles. The jet therefore constructs its own conduit as it travels. This magnetic confinement is so effective that the beam can drill through the dense gas in its own galaxy's halo and traverse the near-perfect vacuum of intergalactic space for eons without losing its coherence. It is a self-contained ecosystem of plasma and magnetic fields, a river of energy flowing through a channel of its own making, guided by an invisible hand across distances that challenge our imagination. Observing this engine room directly, however, remains one of the greatest challenges in all of astronomy. The jet launching region around a supermassive black hole is cosmically powerful, but physically tiny, smaller than the orbit of Jupiter. From our vantage point, millions of light years away, resolving it is like trying to spot a single bacterium on the surface of the Moon from Earth. For decades, it was a purely theoretical realm, but that is beginning to change. Telescopes like the Event Horizon Telescope, a global network of radio dishes that creates a virtual Earth-sized observatory, are finally piercing the veil. By achieving unprecedented angular resolution, the EHT has begun to image the very shadow of the black hole in galaxies like Messier 87, a prominent radio galaxy. These first historic images show us the glowing, chaotic ring of the inner accretion disk and provide tantalizing hints of the magnetic structures that must be present. We are for the first time moving beyond diagrams and simulations to obtain direct observational evidence of the conditions at the base of the jet. We are mapping the magnetic fields where they are anchored, testing the predictions of the Blandford-Znajek process against hard data. This is a watershed moment, the dawn of an era where we can confront our most exotic theories with direct observation of nature's most extreme environments. And yet this is only the beginning. The next great leap in our understanding awaits the completion of the Square Kilometre Array, or SKA. Spanning 2 continents, Africa and Australia, the SKA will be the largest and most sensitive radio telescope ever conceived, a vast digital eye on the universe. Its capabilities will revolutionize the study of radio galaxies. With its exquisite sensitivity, the SKA will be able to detect the faint polarized synchrotron glow from thousands of previously unknown jets, creating a vast catalogue to study how these engines evolve over cosmic time. It will be able to map the magnetic field structures within the jets and lobes with a precision we can currently only dream of, allowing us to test our models of jet collimation in exquisite detail. Perhaps most critically, the SKA will probe one of the last great unanswered questions. What are the jets actually made of? Are they composed purely of lightweight electrons and positrons, a pair plasma, as many theories suggest? Or do they also contain heavier protons and atomic nuclei dredged up from the accretion disk? The mass of the particles in the jet dramatically affects its momentum and how it interacts with its surroundings. The SK will be able to distinguish between these models by studying how the radio signal is altered as it passes through the jet's magnetic field, finally revealing the true composition of these cosmic fire hoses. We are on the verge of moving from a broad strokes understanding to a detailed physical characterization of these incredible phenomena. The whispers from the void are about to become a roar. And so we arrive at the edge of our current understanding, looking back from a vista of knowledge that would have seemed like pure fantasy to the pioneers who first detected that faint, inexplicable hiss from the heart of the Milky Way. Our journey has taken us from a mysterious static in an early radio antenna to the very precipice of cosmic creation, guided by the loudest, most ferociously energetic voices in the universe. We began with ghostly smudges on photographic plates galaxies that appeared deceptively tranquil in visible light, harbouring a secret violence that only radio eyes could see. What were these bizarre, dumbbell-shaped apparitions, these invisible clouds of energy dwarfing their parent galaxies stretching for millions of light-years across the intergalactic void? For decades they remained one of astronomy's most profound enigmas, cosmic phantoms without a plausible physical explanation. We saw how the puzzle pieces began to fall into place, how the concept of a supermassive black hole, once a theoretical curiosity, emerged as the only viable candidate for the engine capable of unleashing such cataclysmic power. We have journeyed down the throat of the accretion disk, a swirling vortex of superheated matter, a gravitational mill grinding stars and gas clouds into plasma. There, in that final, desperate spiral towards the event horizon, we witnessed the birth of the jets, twin columns of particles and magnetic fields flung outwards at nearly the speed of light by forces we are still struggling to fully comprehend. These are not mere fountains of light. They are cosmic particle accelerators, gravitational gyroscopes spinning magnetic fields into conduits of raw power, celestial blowtorches capable of sterilizing entire galaxies. We have tracked these relativistic beams across unimaginable distances, watching them punch through the interstellar medium of their host galaxy, inflating into colossal mushrooming lobes of radio-emitting plasma. We have learned to read their structures to distinguish the feathery diffuse plumes of one type from the intensely bright edge-defined hotspots of another, using their very shape to diagnose the power of their central engine and the density of the environment they are ploughing through. From a bewildering collection of radio static, we have assembled a sophisticated and breathtaking picture of cosmic titans. But to truly grasp their significance, we must now ask the ultimate question: what is it all for? Is this staggering expenditure of energy enough to outshine 100 billion stars merely a spectacular but inconsequential side effect of gravity's dominion? The answer we have discovered is a resounding no. These radio galaxies are not isolated curiosities. They are fundamental architects of cosmic structure, the powerful sculptors that have shaped the universe we inhabit today. Their influence is a story of profound and violent feedback, a cosmic regulatory system operating on the grandest of scales. Consider a young, massive galaxy brimming with cool, dense gas. Left to its own devices, this galaxy would be a runaway stellar nursery, its vast reservoirs of fuel collapsing under their own gravity to ignite a firestorm of star formation. It would burn through its resources in a brilliant but brief cosmic flash, growing into a bloated, oversized behemoth, a type of galaxy we simply do not see in the local universe. Something is holding them in check. Something is acting as a cosmic thermostat, preventing this runaway growth. For decades, this was a critical inconsistency in our models of galaxy evolution. Our simulations produced galaxies that were far too massive, far too brilliant compared to the reality we observed. The missing ingredient, the regulatory force, was the supermassive black hole. Just as the galaxy's gas attempts to cool and settle towards the centre, it provides the very fuel that awakens the dormant monster within. The black hole begins to feed, the accretion disk ignites, and the jets are launched. They tear through the galactic core with unimaginable force, heating the surrounding gas, stirring it into a turbulent frenzy, and blasting a significant portion of it out of the galaxy altogether. It is an act of cosmic pruning. The black hole, in its violent feeding frenzy, effectively sterilizes its own pantry, cutting off the supply of coal gas needed to form new stars. This process known as AGN feedback is not a subtle one. It is a galaxy-wide gale, a shockwave of energy that dictates the fate of trillions of stars. The radio galaxy in its loudest phase is effectively shouting at its own gas clouds, "You will not collapse. You will not form stars." This cycle can repeat over millions of years. The jets switch off, the gas begins to cool and settle once more, star formation tentatively resumes, and then the black hole reawakens, launching a new offensive. It is a delicate, self-regulating dance of creation and destruction, a gravitational heartbeat that ensures a galaxy grows at a measured, sustainable pace. Without these powerful radio outbursts, the universe would look fundamentally different. Galaxies like our own Milky Way might have grown far larger, exhausting their gas reserves billions of years ago, leaving them ancient and moribund in the present day. The cosmic web would be dominated by overweight giants, rather than the rich and diverse tapestry of spiral, elliptical, and irregular galaxies we see around us. The jets are not just agents of regulation, they are also agents of distribution. As they erupt from the galactic core, they carry more than just energy. They dredge up material from the very heart of the galaxy, material enriched with heavy elements, carbon, oxygen, iron, forged in the hearts of long-dead stars and churned within the accretion disk. These elements are the building blocks of planets of life of us. Without a way to escape the galaxy's immense gravitational pull, these vital ingredients would remain locked away, forever trapped in the galactic center. The radio jets are the universe's most powerful distribution network. They are a galactic circulatory system blasting these heavy elements far out into the tenuous gas of the halo and even into the desolate voids of intergalactic space. This material then seeds the cosmic medium, enriching the primordial hydrogen and helium with the stuff of future worlds. When you look at the elements in your own body, you're looking at stardust that has undertaken an epic journey. Some of it may have been forged in a star swallowed by a supermassive black hole, and then hurled back out into the cosmos on a relativistic jet, travelling for millions of light years before eventually finding its way into the cloud of gas that would one day form our sun and its planets. These loud galaxies are cosmic gardeners sowing the seeds of future potential across the vast, dark fields of the universe, and their influence extends even further to the largest gravitationally bound structures in the cosmos galaxy clusters. These are immense congregations of hundreds or even thousands of galaxies, all swimming in a vast, searingly hot atmosphere of intracluster gas visible only to our X-ray telescopes. According to our models, this gas over cosmic time should be radiating away its heat, cooling and catastrophically collapsing into the cluster's center. This cooling flow should trigger a burst of star formation on a scale that dwarfs anything seen in a single galaxy, creating a central supergalaxy of truly absurd proportions. Yet again, when we look at the universe, we don't see this. The gas in the heart of clusters is far hotter than it should be. Something is reheating it, constantly stirring the pot to prevent it from settling. And when we point our radio telescopes at the heart of these clusters, we find the culprit. Almost invariably at the center of the cluster lies a colossal radio galaxy, its jets actively pumping energy into the surrounding medium. The giant radio lobes, inflated by the jets, act like immense pistons pushing against the hot gas. They carve out vast X-ray dark cavities in the intracluster medium, some of them hundreds of thousands of light years across. These are not empty voids, they're ghostly bubbles filled with the relativistic plasma from the jets. As these bubbles rise buoyantly through the cluster's atmosphere like air bubbles rising in water, they drag hot gas upwards, creating massive currents and turbulence that distribute the jet's energy throughout the cluster core. The energy injected by a single radio galaxy outburst can be enough to counteract the cooling of the gas for hundreds of millions of years, perfectly balancing the cosmic ledger. It is a breathtakingly elegant solution to a major cosmological problem. The universe, it seems, has its own regulatory mechanisms, and radio galaxies are one of its primary tools. They are the gatekeepers of galaxy clusters, the cosmic thermostats that prevent the universe's largest structures from boiling over. From regulating the birth of stars in a single galaxy, to distributing the elements of life across the void, to policing the growth of entire clusters, The impact of these objects is woven into the very fabric of cosmic history. They are not just loud, they are essential. And yet, for all that we have learned, our journey is far from over. Our sophisticated picture is still traced with lines of uncertainty. Our map of knowledge still contains vast, unexplored territories. The grand questions that remain are as profound as those we've answered. We still do not fully understand the mechanism of the central engine. How precisely does the spinning space-time of a black hole coupled with the magnetic fields of the accretion disk conspire to launch these perfectly collimated jets with such staggering efficiency? Is it the spin of the black hole itself, or the configuration of the disk that is the dominant factor? The physics at play occurs in a region of space-time so warped and violent that our current theories, general relativity and quantum mechanics, begin to break down. To truly understand the jet's origin is to peer into the heart of a physical singularity, a quest that pushes the absolute boundaries of human knowledge. We also grapple with the mystery of their life cycle. Why do some black holes launch powerful jets, while others of similar mass and with ample fuel remain dormant? What causes the jets to flicker on and off over millions of years? Observing these cycles is like trying to understand the seasons by watching a tree for only a single second. We see snapshots, active jets here, fading ghost lobes there, and from these ephemeral moments we must reconstruct a history that unfolds on timescales far longer than our own civilization. And what happens when these engines of creation collide, as galaxies merge their central supermassive black holes, are destined to begin a slow, inexorable death spiral, eventually coalescing into a single more massive object. The titanic collision of two such monsters would unleash a storm of gravitational waves, a ripple in space-time itself. But what would it do to the radio jets? Would the merger trigger an outburst of unprecedented power, or would it disrupt the delicate machinery silencing the engine for eons? Answering these questions requires a new generation of eyes and ears on the universe. We stand on the threshold of a new golden age of radio astronomy. Telescopes like the Kilometre Array, a continent-spanning network of dishes and antennas, will provide a view of the radio sky with a sensitivity and resolution that is difficult to even imagine. With this incredible machine, we'll be able to detect the faint whispering radio signals from the very first galaxies to light up the cosmos to witness the moment the first supermassive black holes ignited their jets and began to shape the infant universe. We will map the intricate web of magnetic fields within the jets themselves, watching them twist and dance as they propagate through space, testing our theories of plasma physics in a laboratory larger than the galaxy itself. We will be able to survey the entire sky for the fading ghostly relics of past outbursts, creating a cosmic archaeology that will reveal the full violent history of black hole activity over the past 13 billion years. We will move from still photographs to moving pictures, watching in near real time as knots of plasma are ejected from galactic nuclei and race outwards along the jet stream. The era of discovery is not ending. It is just beginning. Our quest to understand the loudest objects in the universe has been a journey into the profound interconnectedness of the cosmos. It has shown us that nothing exists in isolation. The smallest scales, the quantum chaos at the edge of a black hole, are directly and powerfully linked to the larger scales, the evolution of galaxy clusters spanning tens of millions of light years. It has revealed a universe that is not static or serene, but is constantly being shaped and sculpted by feedback by a complex interplay of gravity, matter, and energy. These radio galaxies are the ultimate expression of that interplay. They're a testament to the fact that even from the most destructive force we know, a black hole's gravity can spring a phenomenon that regulates growth, distributes the seeds of creation, and maintains cosmic balance. They are the universe's symphony of creation and destruction played out in a key that our eyes can never see, but which our ingenuity has finally allowed us to hear. When you next look up into the silent, star-dusted night, remember the hidden reality that our radio telescopes have unveiled. Remember that between those quiet points of light, invisible empires of energy are expanding, powered by gravitational engines of unimaginable ferocity. Remember that the very structure of the cosmos, the shape of the galaxies, and the distribution of the elements that make you have been profoundly influenced by their violent radio-loud shouts. They are the cosmic lighthouses in the eternal darkness, the ghosts in the machine of the universe, the loudest, most powerful and perhaps most important voices in the grand cosmic ballet. And we have only just learned how to listen.